Hey folks, what we're going to do today is we're going to take a look at speed, which is distance over time. So let's figure out this wave that we've got here. So I have a particular situation where I can go and I can drop water down. And as the water drops down, it makes a water wave. And you can see that water wave moving left to right. So with this, what we can do is we can go and figure out what the speed of the wave is by knowing the distance and the time. So what I'm going to do is I'm going to bring this little timer down here and see if this timer is going to help me. And what I'm going to do is I'm going to sit here and say, well, you know what? I need to get a distance. So the distance I'm going to use, and as you see me moving this wave over, I'm going to go and move this wave until that very, very first upward amplitude is right at the 2 centimeter mark, which is basically right there. Now what I'm going to do is I'm going to get my timer to start, and I'm going to figure out how long it takes to do those particular 8 centimeters. So here we go. So I start it, and it's moving down. And I'm going to stop it here because I want to get to the exact point where I want to go. So I'm going to do this, and I'm going to go over, and that looks about good right there. So the time is 4.84 seconds. And if I take a look at the distance is from the 2 to the 10 centimeters, so it's 8 centimeters. So if I go speed is distance over time, that is going to be 8 centimeters over 4.84 seconds, 1.65 meters per second. Pretty cool. Now there's something else I can do here too. Because what I can do now is I can use my wave equation, which is velocity is wavelength times frequency. So the first thing I can do is I can bring down this little ruler, and I'm going to do a wavelength. Now remember, a wavelength is from one position to the same identical position on the next wave. So I'm going to go to the crest. So I'm going to move this guy down here to this crest, which is right about here. That looks pretty good. It's a little bit tricky to get this, but I will do the best that I can relative to it. So I'm going to go with that guy basically being right about, and I need to put my graph back on, right about there. And I'm going to take this side, and I'm going to run this guy over until I go and I hit the other height. Let's see. You know, that looks actually not too bad, about 2.8 centimeters. So that is my wavelength. My wavelength is 2.8 centimeters. Now the question is, how many waves do I have in that particular area that we're talking about? Well, the frequency itself we're looking at is going to be from that 2, that's the crest, to the next crest, to the next crest, to the next crest. Well, that gives me 3 waves. So that means I have 3 waves in that 4.84 seconds. That works out to be 0.62 hertz. Now, if I go and I take my wavelength times frequency, I'm going to take my 2.8 centimeters, multiply by the 0.62 hertz, and I get 1.7 meters per second. In the other one, we had 1.65. That is extremely close. So we can see there are 2 ways to be able to figure the speed of a wave. One is simply distance over time, and the other is wavelength times frequency.